Thank you for joining. Okay, so I will get started. Thank you for joining today's webinar, BD FACSDiva Experiment Creation in BD Research Cloud. To create a free account for BD Research Cloud, just go to bdresearchcloud.com. Excuse me. If you already use the FlowJo portal, BD Access portal, then log in using those same credentials. So if you have a portal account, you put the exact same email and password, and that will log you into BD Research Cloud. However, you don't have to have a FlowJo account to access BDRC. If you don't, then you just click on the Create Account and enter your email, and that will prompt you to create an account. For today's webinar, we're going to start with a quick overview of BD Research Cloud. Then we'll move into how to upload a cytometer specifically for BD FACSDiva experiment creation. And then lastly, we'll jump into creating that experiment in BD Research Cloud. This webinar is being recorded. And if you want to see the recorded version of this webinar, you just need to go to flowjo.com. Under the Learn tab, click the first drop-down, Webinars. This is where you'll find upcoming live webinars that you can register for. And if you keep scrolling down, you'll see the previously recorded version. So today's webinar will end up there. Below the webinars drop-down, you can find FlowJo University. This is where you can find short 5 minutes or less videos about commonly used features in BD Research Cloud. So here you'd go to BD Research Cloud, then either you want to get started in BDRC or organize your lab. If you click on the first option, then you see a series of short videos. Here is defining your own cytometer. All right, so BD Research Cloud, what is it? It's a suite of online tools designed to streamline and improve the entire flow cytometry workflow. Within BD Research Cloud, you can upload, save, and share cytometer configurations, and you can also remotely view and monitor the instrument's QC reports, trends, and storage if connected to RSS, which is the remote support service that's with BD. For reagents, you can create panels using reagents from the BD catalog, or you can use custom reagents using fluorochromes from other vendors. You can manage your reagent inventory, so keep track of which reagents are currently in your lab, their location, their titration, and you can create staining sheets with this information. You can also use your mobile phone with BD Research Cloud to open up your camera and scan the QR codes that's located on the BD reagent vials. So scanning that code will give you access to the reagent's information, where you keep it in your lab, so the lab location, which fridge, which box. You'll quickly be able to access its titration information and quickly add it or update the inventory. So if you've run out, you can add it to your wish list. Or if you've just received an order, you can scan it to enter it into your inventory to make sure everything's up to date. There are also workflows that you can create and perform in BD Research Cloud. These workflows can either be experimental type workflows like protocols, or they could be more lab maintenance type of workflows. So cytometer maintenance logs, who did the last monthly clean, when was it done, is it time to replace a consumable or schedule a preventative maintenance? So all these tasks can be kept track of in BD Research Cloud. And when you perform the task, there's a timestamp of who did what and when. And you can also set up recurrent features. You can also create BD FACSDiva software templates away from the cytometer. So this is great, especially if the cytometer is in another building. You can create your experiment from any computer within BD Research Cloud. So when it is your turn to jump onto the cytometer, you don't have to spend money paying for that cytometer just for data entry. You hit the ground running and you just import your experiment directly into Diva and you can start acquisition. There's also some nice features within BD Research Cloud. There's an easy copy and paste section if you have a lot of keywords to add. Of course, we always encourage that you add keywords before acquisition. This ensures that the information in those keywords gets embedded into the FCS file and is always available for you for analysis. Those are never separated from your actual data. There's also one-click end-by-end plots. So you can add multiple plots at once easily in BD Research Cloud. So when you import it into Diva, you don't have to manually create them one by one. And finally, there's a file storage component of BD Research Cloud to upload, organize, and share your data. So you can upload your FCS files directly to BD Research Cloud, and FlowJo version 10 can connect to these files, download them to your workstation, and you can save your most recent version of FlowJo Workspace into the cloud and access it from any computer. This is nice, especially if you're working collaboratively on the same workspace. So you're always working off the latest one without having to manually copy and paste that version. Great. So once you've logged into BD Research Cloud, you land on the home page. So this is what it looks like. And at a glance, you can see the different sections of what you can do within BD Research Cloud. Up here is the panel section. This is where you can create panels or view existing panels. BD Research Cloud comes preloaded with existing panels. So there's a large library of OMIPs and also BD optimized panel. And what's great is that you can also search through these panels using multiple antigens. In the section over the experiment, this is where you would create your FACSDiva experiment file. So we'll dig deeper into this a little bit later. Here is where you would create and manage your workflows, keep track of who did what and when in the lab. Here's the data section where you would find all your uploaded FCS files or other documentation. You can upload protocols, Word files, any kind of data up here. Cytometers, this is the section where you would go to create your cytometer or connect to a core lab cytometer. So we'll be exploring that section a bit more in just a little bit. Reagents, this is where you keep track of your reagents. So you manage your reagent inventory, update titration information, expiration dates, all that fun stuff. Populations is where you can define which markers are used to define a certain cell subset. So you would add what marker is there, what antigen density is expressed for that particular cell population, and you can use that information within panels. This is particularly helpful if you're always defining cells a certain way. You don't have to retype that information over and over every time you create a panel. So you just create it once in populations and then use it in the panel section. The last two sections are about organization of BD Research Cloud. So you can organize your data in different groups and projects. Projects live within a group, so you can have multiple projects within a group. And when you invite users to BD Research Cloud, you can invite them to one or more group. So if they belong to the group, they can see the data that belongs to that group. But if they don't belong to that group, then they won't see that data. So if you need that level of separation, that can be done in BD Research Cloud, or alternatively, you just create a single group and put everything there and everyone belongs to that group and they get to see everything. So it's flexible and is made to suit your needs. In the user section, you assign your users, you invite new users, you assign them to groups, and you can also determine what permissions the individual users have. So if they're allowed to create cytometers, add custom reagents, edit the data, delete the data, or if it's a view-only type of permission. So for today's webinar, we'll start off with uploading a cytometer. So to do that, you would navigate over to the cytometer section. You can either click directly on the tile or on the tabs above. They both bring you to the same place. Once you're in this cytometer section, just click the Add button, and that will open up the next window. There's different ways of adding a cytometer in BD Research Cloud. So for today, since we're doing the BD FACSDiva experiment creation, I will show you how to import a cytometer configuration that runs FACSDiva. So this is this first option, import BD FACSDiva file. You would just enter the cytometer nickname, whatever you call that cytometer, and then you upload the configuration file. The configuration file you would get from Diva. So from within Diva, you navigate over to the cytometer tab and click View Configurations. Once you click there, it brings you to the configuration section where you might have more than one configuration. So for each one, you'd want to export the configuration, and that will generate a CSV file. And that is what we will import into BD Research Cloud. It's very important that you use this configuration file if you plan on creating experiments for Diva in BD Research Cloud, because there needs to be a perfect match between parameter namings between your instrument and BD Research Cloud. So if you do it this way, then you are sure that everything will match up perfectly. So back to the import FACSDiva, once you've selected the file and imported it, it will turn green. And if you keep working your way down, you will need to add a lab location for this cytometer. So if you don't have a lab location, just click the blue button. It'll open up a new window, and this is where you add lab location information. It's important, particularly if you plan on sharing this cytometer with users, to put as much information in this lab location field to make it easy for your users to find your cytometer. So in this case, I put Emilie's Core Lab, Emilie's my first name, and then EJ University, Broomfield Campus. So if you have a core lab, put out the full core lab name and its abbreviation and its university and any other information you think your users might use to try and find your core lab. And I'll show you later why that's important. So once I've added the lab information, I can select it and then scroll down. The last option here, whenever you're adding a cytometer to your BDRC organization, is you determine if it's publicly discoverable or not. Publicly discoverable just means that you are allowing anyone within BDRC, within the whole world, to find your cytometer. And by finding it, the only information they get is its configuration information. So they would use that configuration information to design a panel or to create a FACSDiva experiment. So they don't gain access to your cytometer. They can't edit or modify it. All they would do is read only configuration information. So if you're a core lab, we strongly recommend, or not strongly, we would suggest that you make your cytometer publicly discoverable so that your users can find you. And by making it publicly discoverable, it also means that you don't have to invite all your users to your BDRC organization. They can create their own organization. You don't have to manage them at all. All you have to do is upload your cytometer and they will find you. So that makes the burden much easier, and it doesn't fall onto the core labs itself. Conversely, if you don't want to share your cytometer, it's yours and you don't want anyone else using it or seeing it, then just don't check this box, and the cytometer's information will stay within your organization, and only users within your organization will be able to use that cytometer to create a panel or a BD FACSDiva experiment. So once you've filled in this information, so just importing the file, giving it a lab location, and deciding if it's publicly discoverable or not, you would click the Add Cytometer button. What happens very commonly is that the model name is not included in the exported file that you got from Diva. So we just let you know the model is not recognized. Click the Edit button and select the model from the dropdown. So just click this little Edit Pencil button, and it'll show you a list of Diva running models. So you just scroll down to select the correct one, you click on it, and then it will update to show the correct model name up here, no more error warning. You would just click Save and then Publish. So publishing means that you're done editing the cytometer and you're ready for others to view it. If you don't press Publish, then it's still quote unquote in design. You're not done editing it, so it's not available to other users. But if you're done then and ready to share it, just press Publish. And again, the publicly discoverable will say if you're sharing it with everyone or just sharing it within people within your organization. Once it's published, the cytometer's configuration information and parameter naming scheme is then available to be used for Diva experiment creation or panel creation. So here, if I was a user of a core lab and I wanted to search for a cytometer to connect to build a panel, I would, again, go to the cytometer section, click the Add button, but this time, instead of importing a FACSDiva file, I would search in the Add a Public Cytometer. So publicly available cytometers will show me all the cytometers of people who have checked that publicly discoverable checkbox. So in this search box is how I would find a core lab. For example, here I can search for Fred Hutch. So once I find it, I click on it, then I will see all the available cytometers that are available for Fred Hutch. If I want to connect to one, I just click it and then I press link cytometer. And then that cytometer becomes quote unquote one of my cytometers in BDRC. And so that simply just means that I can use the configuration information to create a panel or an experiment. So for this slide, I wanted to show add a public cytometer if I wanted to search for the location, the lab location that I created. This is how users would find me. So I put either EJ for EJ University or Broomfield for the Broomfield campus or Emilie for Emilie's core lab, right? So that's why lab location, you want to be quite descriptive in that field because that's how they find you. All right. So now it's time to jump into the FACSDiva experiment live demo. So I'm going to jump away from these slides and switch to BD Research Cloud. And let's just sign out. So again, the address is bdresearchcloud.com. You put in your Flojo portal ID credentials. If you don't have these yet and you need to create them, just hit the create account button down here. Put your email and follow the instructions. Once you have your login, you sign in and you land on the homepage. So here, if I go to the cytometer section, you will be able to see my cytometers. So these are cytometers that I've either uploaded myself or that I've connected to a core lab cytometer. So this is the one that I have created for myself and made public in the EJ University lab location. So today we're going to use this A5SE to create a panel and then also create a FACSDiva experiment. So if I go to the panel section, so I can either click the tab at the top or any of one of the tiles, right? So there's a one-to-one sync here, panels, experiment. So you can click either the tabs or the tiles. If I go to panels, there are different tabs within the panel section. Custom panels shows any panels that I or anyone in my organization has created. So these are all custom panels. In the published panels, this is where I would find OMIPs. So for example, I can click on OMIP 83. I see a summary of what OMIP 83 is. I can also see which cytometer was used to create this OMIP. So the Cytec Aurora. And I can click on visualizations. So I'll be able to see the spectral signature of the OMIPs and then the similarity matrix or the hotspot matrix. BD defined panels is self-explanatory. These are panels that have been developed by BD. So if I click this 5-laser T cell senescence and exhaustion panel, here are the panel details. The OMIPs and the published panels, the BD panels, all have a link to a citation. So you can click on this link to get more information about these panels. So this panel came from the Interactive Human Cell Map. So these are T cells, view panels. So this was the 5-laser T cell senescence panel that we were just looking at. You see which cytometer it used, LSR 42620, and the visualizations. So you can click on each laser line. Since this was a conventional cytometer, you have the combined view or the stacked view, which shows you laser line by laser line. It also shows you cross laser spillover. So the PE-Cy7 here is primary on the yellow-green, but in other lasers, it'll show you a dashed line to show you how much spillover is carrying over. Great. So if I were to create a panel using the imported cytometer configuration, I can either create a panel from scratch or I can search for a panel that might suit my need. So in this case, I can search through the panels using the All tab. And I can filter by antigen. So let's say I'm interested in NK cells. So I can look for CD56, CD16. Let's say I also care about monocytes. I'll add CD14. And as you see, as I add more and more antigens, the list of panels filters down to only panels that meet this criteria. So let's say if I add FOXP3, which is a Treg, it might, there we go. So it restricts the search to only panels that contain all these markers. So for today's purpose, what I'm going to do is just assume that I like this 5 laser T cell senescence panel, and I want to know, so it was created on an LSR4 Tessa, is it compatible for my A5SE that I've just uploaded? So in this case, what I can do is use this panel as base. So instead of creating a brand new one, I want to use this as a base and make some edits. So I'm going to click use this panel as base. I'm going to give this panel a name. So I'm just going to give it a date, T-cell webinar. I save it to a group, to a project, and then cytometer here. I get to select what cytometer I want to assign it to. So I'm going to assign it to my A5SE that I just created, select the cytometer, and now it will update. I also get to choose what I keep from the original panel. So do I want to keep the original clones, or I don't really care about the clones and all I care about is the antigen and fluorochrome pairing. So if I want to be able to view the most amount of fluorochromes, I don't want to restrict it by clones. So I'm going to remove the clones. And then I can choose to either keep the fluorochrome pairings or remove them and just keep a list of antigens. So for today, I'm going to keep the full list of fluorochrome pairings. But if I didn't want any particular antigen, I can remove them here or in the next step. So once I've selected the cytometer, removed the clones, I can then move on to the next step. So now it brings me to step 2. Step 1 is selecting a cytometer. Step 2 is finalizing the antigen list. I'm going to add a viability dye to this panel and assume I'm happy with the information. I could have deleted and added on this step, but for today's demonstration, I'm just going to leave it as is. So since we selected a panel to use as a base, these come pre-paired with their fluorochromes. So CD3 has been paired with BUV 395, just like the original panel, but I'm not stuck to this decision. This is just showing me what the original panel was, but if I want to make some modifications, I can unpair it. CD3 then goes down here, and I can see what else CD3 is available in and what I want to assign it to. So assuming I like BUV 805, I can click pair, and then it just saved that modification. I also added a viability dye, so I will choose which viability dye to assign it to. You'll notice that there's some red boxes around some of the fluorochrome choices. If I hover over it, it says, oh, this viability dye has a 0.9 similarity score with something else. So it's telling me that's not a great choice. If I were to click it, then you can still pair it, but you can see that it's very similar to something that's already there. So this one is the green one that's overlapping. So it's highly similar and not recommended to be used. If I don't want to see any of these warnings or the fluorochromes that have the warnings, I can say hide conflicting fluors. So it'll get rid of any choices that's deemed questionable, and it just leaves me with better choices. So this makes the choice a little bit easier. So fixable viability stain. Let's go ahead and add one over here. Perfect. So since I have a spectral instrument, I have access to the hotspot matrix. So I can glance over here to see if my score is good, if the similarity matrix is acceptable. And if everything looks good, then I can proceed with the final steps of panel creation. On step 4 is where I would finalize the test size and the clone options. So for CD3 BUV805, it comes in SK3 clone or in SP34-2. And so I can scroll and decide which clone I want to move forward to. I can always click the Learn More tab for a particular reagent, and it'll bring me to the BD page where I can look up citations, references, and any other information specific for that reagent. So once I've made all the choices, I can complete this step. And the last step is finalizing the shopping list. So if some of these are already in your inventory, you can see with the little check mark. So if I hover over the check mark, it lets me know, oh, I already have this one in my lab, and I already have this one in my lab, but I don't have this one. So this one I'll need to order. This one I already have. So if I want to remove in inventory items, I can just click here, and items with a check mark move down below. And I can also manually remove some. And then once I'm happy with the shopping list, I can move on to the very last step. I can send the reagents to the BD cart for ordering, or I can email the shopping list to the purchasing person of my lab. And then lastly, I can view the panel. So here's my finalized panel that I used as a base. Cytometer is the A5SE one, and the visualizations that come along with it. I can also create a staining sheet. So the staining sheet is how I would stain cells using titrations that I've added in my inventory. So many of these reagents were already added to the inventory and titrated. So when I create a panel with these reagents, I then have access to the titer that I've entered, and I can create a staining sheet. So I won't go into detail about how to create staining sheets, but if that's of interest to you, feel free to reach out to me anytime. Happy to walk you through. Or if you want to watch one of the webinars, we explain that more in detail there as well. So let's hop into experiment creation. Now that we've uploaded a cytometer and we've created a panel, we're ready to create that DIVA experiment. So to do that, we would go to the experiment section. So again, either the tile or the tab will bring you there. This is a list of past experiments that others have created. I can either duplicate it or edit it or create a brand new one. So for today, I'm going to create a new one by pressing this blue button in the upper right corner. I need to give this experiment a name. So I will just leave the default name, experiment, say webinar, assign it to a group, and pick a cytometer. So I will pick that A5 SE webinar that I created with the FACSDiva exported configuration. It already came with a FACSDiva version. If you used FACSDiva to import the configuration file, it should come with the Diva version. If ever it doesn't, you can always select all options. So this will give you a list of all the versions, and you can select the good one, the correct one, or if you need to type one in, you can also type one in here. But I will just use the selected cytometer FACSDiva version. If your cytometer comes with an HTS device or a plate loader, you can click Start with a Plate Editor. If you don't click it, then it'll just bring you to the tube view. So for today, let's go ahead and create a plate. So then I would go and click Add Experiment. If ever I want to confirm the cytometer that I've used, I can always expand the laser details here and confirm that this is the correct cytometer that I plan to run my samples with. All right, so then collapse this and add experiment. All right, so let's go ahead and start by adding a plate. So it's this big button up top, add a plate, 96 well U bottom. You can click on any well and type in information for your specimen. So I can say specimen 1, add specimen. If I want to remove it, click the trash icon. You can select multiple wells to create specimen 1, add specimen. Or what I prefer to do is the autofill. So if I delete this and I just select the whole area with all the specimens, and then I can click autofill selected. Oh, here I forgot to highlight that you pick what kind of plate you start off with. I would always use U-bottoms, and then I can autofill. This just asks me what pattern you want to fill it in as. So I like to fill it vertically, number of wells per specimen. So let's say 3 wells per specimen. And if I want to put any kind of prefix, I can. So patient ID, I will add and press autofill. So now it goes patient ID 1, 2, 3. So it goes vertically for 3 and it autofills them for me. I can always edit any one of them by clicking and then, I don't know, updating the name or just keeping it the original name. Doesn't matter. If you have complex names for the specimens, I recommend that you just leave the default name and in the keywords, you can copy and paste those specimen names. So we're gonna definitely go through that in just a little bit. So for now, if these are just generic, so let's say here we can delete them, even if I didn't add a prefix. The autofill selected, going down vertically for 3, and I'm gonna leave this blank. It's just going to do the default specimen in 1, 2, 3. And for now, I'm okay because I'm going to use the keywords to overwrite these words all at once. Other things I can do here, you can rename the plate to something else other than plate 1. You can duplicate this plate if you have more than one that have the same pattern, or you can delete the plate if you have created multiple plates and need to remove any of them. I believe that is all for this section. So what I'll do is press continue. And that will bring me over to the next section. So because this is a plate, it is ordered by specimen. If I scroll to the bottom, I will also see tubes. So if I need to manually add some tubes outside of the plates, I can do that. I can click add specimen and it'll add a tube. I can add another tube. And so that's how you would add tubes to your experiment. But for now, I'm just going to leave the plate. So I will go ahead and delete this specimen. It now lists the parameters at the very top. So with the scroll bar, I can see with the A5SC, there are lots and lots of parameters. You can manually enter your panel information here, enter a column value. So here I could say CD3, BV 421 if that was my panel, and I can update the column and I can do this manually. I believe that's how you have to do it currently in Diva. So instead, enter a column value. Oh, wait, so I'm going, if I want to delete this, I can select all and say clear selection. So never mind, I don't want to do it that way. So we have the select all and unselect all here. Instead of entering the panel information manually, which is 1 long and 2 error prone, I can make typos or mistakes. I can just look up the panel information that's already entered in BD Research Cloud since I just created that panel. So I'm going to select all specimens and come look for my panel here. So the panel had today's date, I believe, which is 10. There we go, T-cell webinar. So this is the panel that I just made a minute ago with all of you. And if I click that, I can then choose to apply panel. Right now, it's going to add the antigen and the fluorochrome. I can choose to add the clone information too. So let's go ahead and do that. So now you can see it added CD4, BUV 496, and the clone of the reagent that I added. And it added that correctly to all the parameters. If I want to hide the unused parameters, I can then come here and double check that everything was entered properly. If I find these names are way too long with the clone, let's go ahead and select all, clear the selections, and do this again. Oops, select all, and let's apply the panel. Oh, sorry, I forgot. Meant to remove the clone. So let's select all, clear, select the panel, unselect the clone, and then apply the panel. There we go. So now we can see just the antigens and the fluorochromes have been added here. No typos, everything's nice and neat. And it also put them on all the right detectors. If you have different panels for different wells or plates, you would just highlight, one plate at a time and click different panels for different wells or different tubes, and then you can just do it easily by clicking around instead of having to manually enter all this information. All right, so let's continue. So we've created plates, we've added our parameter and panel information. Now we're at the keyword state. So remember here I said, oh, just leave the default names because we can replace them easily in the next step. So let me just collapse this. And here I have a, just an Excel sheet with my hypothetical long patient ID names. So here I have 10 specimens. So I will just copy from here and paste them here. And now you'll see that the IDs have been correctly pasted to the specimens. I didn't have to manually type them. Same applies here for any additional keywords. So here I can add stimulation information. I can add demographic information, say age of the subject. So anything that's going to be relevant for analysis where I might want to group or organize the data using this information, it's great to enter it here and now so that it's embedded in the FCS file once the data is collected. So again, this works like a spreadsheet, so I can say no stim, and then a positive control. So then I can shift, copy, paste. I can select multiples at once and paste that, right? So it just makes the entry that much easier compared to having to add them one cell at a time in Diva. So the age here, let's say this is a 2-year-old, if this is pediatric studies, and then I don't know, again, if you have a spreadsheet where you have all this information, you could just copy and paste the whole thing at once. So these are the keywords for the plates. If you also had tubes, you can add the keywords here, but I don't have any, so I would just add it here. All right, moving on to the next step, which is plots. In this page, we have a global sheet. We can create more than one global sheet. So you can have one sheet for your gating strategy and one for your n-by-n plots. What you'll notice is that we have these checkboxes for commonly used plots. So for example, if I like to do forward scatter area versus height for singlets, I can then add a gate type. I can add a polygon with a gate placement of center, top left, top right, bottom left, bottom right. So if, let's say polygon center, we'll add a polygon in the middle here. In BD Research Cloud, you can't drag and drop gates as you can in other analysis softwares. So it just gives you a rough placement, but once you import it into Diva, then it becomes just like a regular gate. So I'll be able to drag it around, resize it as needed. I can rename it here. So let's say this one is going to be singlets. And if I want to add another plot here for size, forward scatter versus side scatter, I can then decide which population it's gated on. So here I want to gate it on the the singlets population. And I can also add a polygon center here and rename it, say, for lymphocytes. So these are commonly used ones up here. And then I can add a custom plot here. So let's add a dot plot gated on the lymphocyte gate. And if I click on the parameter itself, I can decide what I want to gate against. So CD4 or CD27. So these are all the parameters are labeled that were labeled with the panel. And these are just other detectors. So if you want to look at raw versus compensated parameters. So you get the idea that you can create a variety of gates and gating hierarchy. You can name your populations here. So this one could be my gating global sheet. And then in the other gating global sheet, I can use it for n by n. So either just the compensated parameters or all the parameters. So if I remove this one and this one, it has every parameter versus every parameter. And this is where you can check to see how well your compensation or your mixing is looking on your all stain controls. So once I've created all these plots, again, you can delete them, you can add more. I will go ahead and press continue. Cytometer settings is for those that don't use CSNT beads to set your voltages. We definitely recommend that you use CSNT to set your voltages daily for consistency. But if you use some other kind of standardized bead and that you do want your voltages to always be set close to those MFIs of your standardized beads, you can update the voltage here so that when you import it into Diva, it'll have those values. Depending on your instrument, whether if it's spectral or conventional, you can choose to collect all the parameters or only those that are labeled. So I have a spectral instrument, so for that reason, I would collect all the parameters here. But if you had a conventional instrument, you can choose to shrink your data size by only collecting the parameters that contain labels to them. So by pressing this removed unused parameters, anything that didn't have a label will not get collected, and only the ones that did will get collected. So these are just simple checkboxes to determine what you want to collect or not. So lastly, all you have to do is generate that zip file. This will create an XML Diva experiment that you can then import into Diva. From your Diva workstation, you would just open Diva, do File, Import, and import this file. If your cytometer is connected to the internet, what you can do is just connect to BD Research Cloud from your cytometer, log into your account, navigate to the step, and then just press zip. So then you would export it, it would download to your cytometer workstation, and then you could just upload it directly into Diva. Or if your cytometer is not connected to the internet, then you would just do this from a different workstation, and then you can put it on a flash drive and manually import it that way. Once you import the experiment into Diva, if you start acquiring right away and performing tasks, you shouldn't run into any issues. What we have seen is that if you import the BDRC experiment into FACSDiva and then close the experiment right away, it will lose some of its attributes. And the reason for that is that the BD experiment is just a skeleton. It's not a full Diva experiment. And so the workaround for that, from Diva, when you import your BDRC experiment, all you need to do is toggle from the global worksheet to the other worksheet type. You do that once, you just toggle between the two worksheets and then press save, and that's the workaround, and then everything is preserved. So in case you run into that issue, we do have a workaround for that. In BD Research Cloud, we don't allow you to create compensation controls. That's because we want you to run CSNT first on your instrument, and then when you create your compensation controls, it'll use those correct voltages to acquire. So the workflow is that you would come here, label all your samples, import it into Diva, then you would proceed as usual with creating your comp controls, collecting them, unmixing or compensating, and then acquire your data. Once you have collected all your data, you would export your FCS files away from the cytometer workstation, and you can do that either during using BD Research Cloud. So you can upload your FCS files directly to BD Research Cloud, and it will connect to FlowJo. Or alternatively, you just export it to your institutional server or wherever you would typically post them, and then you can perform analysis. I'm assuming this audience uses FACSDiva and might have some gates that they've drawn in Diva that they would like to import into FlowJo. Know that this is possible. In FlowJo version 10, once you pull in your FCS file from Diva, if you just right-click on it, there's a function, import gates from Diva. And all you have to do is refer to the XML file that you exported from Diva. So this is different from this XML. So not the experiment template, but once you've created your, once you've acquired your samples in Diva, when you export your files, if you not only export the FCS file, but if you also export the experiment XML file, that will include all your gates that you drew in Diva. And then you can import that into FlowJo and it will bring in those gates. So you don't have to redraw them. Personally, I would always have minimal gating in Diva, and I would do a lot of my analysis in FlowJo. I didn't do a lot of sorting. I did a lot of analysis. I would do a lot of just post-acquisition analysis. But I know that's not the case for everyone. There's some people that do a lot of extensive gating in Diva, and they would like to recreate that in FlowJo. And just know that you can by using the import gates function and using the exported XML from Diva post-acquisition. So that's what I had for the webinar for today. Let's go back to the slides. I will just show this slide to finish off. There are lots of resources. The first two are the same that I mentioned earlier in the webinar. So FlowJo University, these are short videos, how to, so 3 to 5 minutes on how to do common things like how to create an account, how to upload a cytometer, how to create a FACSDiva experiment, designing a panel, uploading data, connecting to FlowJo, all that fun stuff. Webinars like the one today go more in depth for a particular topic. And so you go here to sign up for a live webinar or watch the recorded ones. My contact information is below here, so feel free to email me anytime with any kind of questions, or you can also email FlowJo Tech Support. And also within BD Research Cloud, there are icons with additional details there. So we have the tutorials where every page of BDRC has different information within the tutorial. And then we also have tech support and commonly FAQs, frequently asked questions within there. So with that, I thank you very much for your attention, and I'm wishing you a great day. Happy flowing.